Thank you so much for coming in. So the topic for today is managing a billion object repository using Alfresco. About myself, my name is Munwar Shariff. I am Chief Technology Officer and co-founder of CIGNEX Datamatics, a company we founded in the year 2000 here in Santa Clara, California based company. I wrote my first ever Alfresco book in 2000. I started in 2005 when Alfresco was version 0.9 or something, and then I released it with 1.0 version in 2006, and I've authored about five books in Alfresco. So this is a quick agenda for today. How many of you attended Andrew's keynote speak today? Keynote topic right on big data. So we are going to twist it a little bit on the big data, and we are going to discuss about big content, basically. So unstructured part of the big data is big content. So we are going to talk about it and see how we are able to address the big content requirements using Alfresco as a platform, tweaking it a little bit in terms of the way we manage the documents. And I'll go through, this is a little bit of technical session, though it is categorized as a business session, because we will also go through some little bit of details about the technology as such behind the scenes, so that you will understand how we are able to scale the platform up to storing a billion objects plus. Then we also pretty interestingly go through some of the technologies we have evaluated before finalizing on Alfresco. That gives you some idea about some other alternative technologies available in the market, and what are the pros and cons of some of those big data technologies as compared to Alfresco as a platform. Then I'll go through the architecture in terms of Alfresco as a big content platform, and then summarize it. So this is the brief agenda for today. And if you have any questions, please feel free to ask anytime. I think we have about 30 minutes time to cover this session. So the business use case for us is to build a social security e-benefit system. So as you know, it's lots of amount of content is involved in managing the e-benefit for social security. I think year 2011, US government has spent about $700 billion in the social security benefits. So that includes benefits for the retired workers. It could be healthcare benefits, food stamps, the housing benefits, the insurance benefits, and so on. And also benefits for the disabled workers, and also for the children who are under the age of 18 years who are entitled for such benefits. So the project for us is to create a repository to store all the documents and also the interactions with millions of people who are going to avail these benefits. Even the employment benefits itself is about 150 million people were employed through the Social Security employment benefits in year 2011. So if you can see the amount of transactions happen with 150 million people interacting with all the government bodies by submitting the forms, e-forms, and so on, and also availing the healthcare benefits, and also keeping the electronic medical records, the job records, the food stamps, the housing loans. So the millions and millions of documents are going to be generated as part of this particular system and being used by millions of people across the United States. So, so there is a portal which is there called My Benefits for a specific state government, and this particular implementation is only for one state government, not across the United States. So you can see that one state government having about 19 counties are able to generate more than 1 billion documents, and you can see the volume of data which is being generated across the nation. Yeah. So for example, the employment services, as I said, there are 150 million people are employed as part of this scheme in 1 year. So the amount of interactions happen with the people, the documentation, the forms they submit, the approval process happen, and then the collaboration, the notifications go to the people, the whole bunch of interactions which are captured as part of the program, and then the cash assistance for the people who wanted to buy house and avail loans, and then the food stamps. How many of you are aware of food stamps program by government? Anybody? So what happens is for the typical household, depending upon the earnings of a family, so they are entitled for a certain amount of food stamps. So usually what happens in few years ago, so their food stamps are literally printed, and those food stamps are posted or mailed to the addresses. And then when they use the food stamps, there is a way of tracking how many food stamps were used, where were they used, how were they used, and so on. Now, to reduce the print media, so people can log in to the system, and depending upon their eligibility criteria, they can download the food stamps and they can take a printout at home and use it as needed. Yeah. And similarly, the healthcare program, all the healthcare benefits, the insurance program, the child care, employment. So lots of interactions, lots of documents have been generated with this particular program, and we need to cover that as part of the system. So these are the objectives of the program when we started understanding the requirements. Or they have documents about last 10 years worth of document. They have to be moved into a repository. They're all in the file system basically so far when we started the project. And people need to have secure access to those documents. The metadata management and search and so on, and then high performance search basically. So here are some of the scalability requirements as per the SLA. So they have about 500 million objects. What are the objects? Objects are nothing but the forms, could be the PDF documents which are created using the templates, could be the Microsoft documents, could be the audio files, could be video documents, could be emails, basically the interactions which happen with the people, the email trackings, or it could be the call records. That means somebody called you and you tracked those call records and stored that audio file into the repository as a proof of that conversation happened with the people in order to interact with them. So they're all about 500 objects. So I call objects because they're all content items. And yeah, and about they have a growth rate of about 60 million documents per year. And again, this is for one state, not for the entire country. Again, within the state, about 19 counties are part of this particular program. So those 19 counties are generating about 60 million documents per year. That means approximately about 5 million per month. So we are expecting that over a period of time, it will get into 1 billion objects. So our basically the mandate is to create a repository which will go beyond 1 billion objects in future. So that is what is the whole objective. And the estimated repository size is about 60 terabytes, but we were aiming at about 150 terabyte because the sizing we have done doesn't include the media documents. It's only for regular office documents. So when you take the media documents like video tracking and then the kind of recording you do for audio, then it will go beyond. Okay, yeah? Okay, cool. A lot of echo though. So the users, actually the users of the systems are millions and millions of end users. But so the interaction with the system repository happens only with 30,000. They are employees of the government, the state employees and then the social security employees. So they're the people who interact with the system, about 30,000 of them. End users are not going to interact with the repository. So that's the reason why you see the low number of users using the system. And very, very important thing for the SLA is the amount, the rate at which we push the documents into the repository. So as per the SLA, we need to have about 200,000 documents pushing into Alfresco every hour. Yeah, so that is the kind of SLA we need because of the inbound documents coming into the repository. And then very, very important is when you look at the performance of the search, the performance varies depending upon the size of the repository. If you have 100,000 objects in the repository, typically search works great, you don't see any issues and all. But if you have 500 million objects in the repository and you want to search on top of that, that is where the performance issues will show up. And we have SLAs where a lot of these documents are searched based on the date range. So we give a date range and you give a lot of metadata, basically a faceted search. That means you have option of filtering out the search results. So basically there is an SLA of pulling about 500 search results which are valid accurate search results in about 2 seconds time. So that is the kind of SLA we have for the API perspective to achieve that kind of performance. And then what they do is a lot of these documents are also stored in the PCL format, which is the print documents, basically. So we need to convert on the fly. When we retrieve these documents as part of the search, outcome of the search, we also have to convert those PCL documents into PDF documents. Okay. Now, the tricky part of that is it's not like 200,000 documents you're pushing into Alfresco repository, or let's not talk about Alfresco right now, because when we started the project, we have not decided which platform to use, actually. So the biggest requirement is the documents we get are in the PCL format. That means they have a lot of XML header content, which we need to read the PCL file, read the XML header, pull the metadata, and separate the metadata from the content, and then push metadata separately than the content. That means we need to break the incoming documents into 2 pieces, the actual binary content and then the metadata. Then load metadata separately into index and then the binary content. So there is a bit of reading the document, slicing the document, extracting the metadata, understanding it, logically grouping it, and then pushing the content. So the lot of processing is involved. It's not just 200,000 binary documents pushing into Alfresco. So a lot of processing is also involved. So we were looking at an engine which does this processing at very, very high speed. So that is also one of the requirements. So what it means is it requires us to develop a platform for something called big content. What is big content? Basically, if you look at big data, there are 2 sides of big data. One is the structured portion of big data, second is unstructured portion of big data, because it's not a relational database model anymore. So when we look at big content, this is where the requirement is. So the types of big content which we need to store into the repository, records and documents is one thing, basically. And then we also have a lot of audio video files, blogs, basically emails as part of the records we get from the customers and basically the users of the system, a lot of social media information. So this is nature of the content, big content. This is unstructured big data as such. And this is the key for us to define a system is the metadata for each one of the content is so different. So what happens is basically, typically most of the systems come up with a core metadata framework, which is the common elements to describe a content, which is a metadata. So we'll have a metadata, and then there is a domain-specific metadata. For example, for all the food stamps, there is a specific metadata we capture for all the food stamps. For all the employment benefits, there is a specific metadata which are part of employment benefits. Similarly, for childcare, there's a different kind of metadata we capture. And similarly for insurance, there's a separate kind of metadata we capture for insurance. So for each and every nature of the content, the metadata is so different. And then there are applications which are created on top of these metadata. So there is application-specific metadata also. So what is happening is that we cannot have a rigid relational database model to store the content because the metadata itself is changing. So you need to have a system which is like a NoSQL kind of database, which is schema-less. That means you cannot have schema-driven based repository. So that is kind of key. Now there are certain technology frameworks available in the market which fits into these requirements. And then MongoDB being one, Hadoop being one, and Alfresco being one, and basically Solr, Apache Solr being one, which are not tied up with a rigid metadata model. If you look at Alfresco, there is something called aspects, which you can define on the fly. That means you can tag in aspect. When you are injecting the content into the repository, you can connect or tag along the aspect to that. That means you are dynamically hooking up or connecting metadata to the content when you are pushing into the repository. So that is the kind of flavor you get with Alfresco. Similarly, MongoDB, if you take it's a schema-less NoSQL database. That means you can create a schema-less based content JSON objects and push into MongoDB. How many of you have heard about MongoDB before? And how many of you heard about Hadoop? Cool, I think everybody here. So if you look at those two, also fall into the same category because that is how those architectures and those technologies were kind of designed in the first place. So this is a very, very important requirement, because the way you define the metadata, the way you store the content will help you, the taxonomy, to pull the data out efficiently from the repository. So this is one big requirement as part of the big content. The other requirement is enterprise search, which is the kind of key thing. You can have 100 million objects in the repository. If you are not able to locate, there is no meaning of having a content management system. You can as well put them into a high-end file system, file storage. You don't need an enterprise content management system if you cannot locate the data and you cannot secure the data. So if you look at the kind of trend, the search is the entry into big content. So if you look at major main players which are in the content management space, they have acquired the search companies. If you look at Oracle acquired Indica as a search engine, Microsoft acquired Fast, which is a search engine. Similarly, IBM have acquired Vismo. Now, what is happening is Alfresco also moving towards a Lucene-based search to a Solr-based search. But if you want to go into the big scale, then you need to go into something called SolrCloud. How many of you heard about SolrCloud? Okay, so that is the new version of Solr, which you can install it on a separate hardware. You can define the sharding policy. That means you can define how you can shard it, whether index-based sharding, and then the way you are going to distribute the search and then the way you are going to basically manage all the distributed search engines through Zookeeper, which comes along with Apache Solr. So it's a combination of Apache Solr and a very, very interesting project from Apache called Zookeeper. Basically, Hadoop uses Zookeeper to manage the storage within Hadoop. So basically, combination of Zookeeper and Apache Solr is SolrCloud. So that is what we have used. We evaluated as part of the solution when we were looking into this. Now, very, very interesting thing is big content requires discovery of the content as well as analysis of the content. That means you should be able to analyze what is the nature of the content you are storing into the system. So one is obviously the discovery. It is like traditional search. You go to search, you give certain keywords, give certain taxonomy, and you're able to find the information. That is your traditional discovery. But analysis is depending upon the nature of the content stored. You can analyze the nature of the content and you can make some decisions based on the analysis. And very, very interesting thing also is we require, as part of the requirement, we also need a fuzzy logic. This is far, far different than full text search. A lot of the content management systems provide full text search. That means imagine a situation where you have full text search and you have 1 billion documents. For each and every search, you end up getting approximately few million results out, where you're looking at 1 or 2 documents, not few million documents coming out of the search. So full text search will not help. What is important is 2 important criteria. One is fuzzy logic. That means you need to understand the content which is related, let's say synonymous to a specific content, or which is related to a specific content. That means you do not exactly know how to search for the content. That means you give certain criteria which will help you to locate the content. And next one is you need faceted search. That means you need to have a faceted navigation, filtering out the results to shorten or to reduce the size of the search results coming out of the system. So with the fuzzy logic based search, which will be able to locate the content, and then the faceted search, which will be able to locate the accurate content, or 2 main criteria for you to define the enterprise search. And then what we looked at is we started evaluating the solutions in the market. And obviously, we need a very, very high-end repository. It has to be API driven. That means a lot of external systems should be able to call it through web services. It has to be high speed. Obviously, this API has to be high speed. Then enterprise search, and then it has to be highly secure. So these are the 4 main criteria for us to evaluate the systems. Then we started looking at alternative options. We started doing proof of concepts to look at, first of all, the feasibility of the technology. Second is the SLAs, the performance. They are the 2 key important things for us to evaluate these solutions. So technical requirements we have is highly scalable repository, the secure access, and one interesting requirement has come up, which is listed as point number 4 here, is as per the regulatory requirements, as per the compliance, they wanted the repository information related to a specific county to be in a physically different storage. That means you should be able to physically separate the storage behind the scenes. That was a compliance requirement. Most of the content management system, you take big data based systems like Hadoop, Mongo, or you take enterprise content management systems like Documentum, IBM Content Manager, FileNet, Alfresco. They give all the content is stored at one location. So you cannot physically separate the file systems. You cannot say, so that is the main issue with most of the content management systems. They're not physically separated because you need to access the system through the API to be able to have a secure access. Because if you physically separate, then you are breaking the security rules of isolating the content. But this was one of the major requirements. From the compliance point of view, they need to isolate the content. So then the criteria has become a little complicated for us to look at which technologies will help us do that. Then obviously standard content management services like version control, workflows, business rules, and so on. And then very, very high-speed web services access of the API, obviously looking at the nature of the content. If you're pushing 200,000 objects, these are all documents, they're not records. So you're pushing 200,000 documents and pulling out, so you need very, very high-speed web services access. The first one we looked at is a combination of MongoDB and Solr and a front-end Java-based portal called Liferay. How many of you heard about Liferay? Cool. So Liferay gives a lot of the UI usability in terms of the basically providing you the secure access to the content and the entire theming, the platform for you to interact with the system. That's what the portal is providing. And then we have MongoDB as the storage, because Liferay's default storage is relational database. That's where it stores the metadata, and obviously it has something called document library. But the document library of Liferay is not scalable. We tried it with 1 million objects. Once we pushed, when we have 100,000 objects and all, the Liferay interaction was working fine. But the moment we crossed 1 million objects, in order to search and pull one document, it was taking about 24 minutes for us to pull the document out. Because what happens is that they have a very, very crazy way of checking the security. That means you read ACL record of each and every document and check whether the person who authenticated or the API which is being called has access to read the document or not. So the moment you started doing security, then if it is 1 million documents which fits into the search criteria, then it takes huge amount of time. As and when the size of the repository increases, the duration increases, you end up waiting for 6-7 hours to read one document, right? So that's where it is. Then we said, oh, there is some issue with the model. Though the MongoDB is able to scale, because we have done fairly large-scale implementation with MongoDB. Right now, we are doing one system for a large legal company in the United States to basically filter out about 600 million records out of MongoDB in a day, not in the lifetime, in a day. So we are processing about, so we have used MongoDB fairly large-scale implementation. So we know the platform is going to scale, but it is not helping us in terms of getting the traditional enterprise content management functionality. For example, security, having a secure access to a document, workflows, for example. So a lot of content management requirements, because it is highly scalable from the scalability point of high performance only from the storage perspective, not from the access through Liferay. Yeah, and then API-based access, because it has API through Liferay. But what is important is we could not get secure access because it's all flat storage in MongoDB. And it's not a traditional ECM, because you don't get version control kind of request, and then workflows, for example. A lot of traditional enterprise content management requirements. Then what we did, basically we evaluated Hadoop, which is another big data platform. And we have done another project for a telecom company, basically managing the call data records, CDR records using Hadoop. So we were processing amazingly about 900 million call data records in 1 hour. 900 million. That is what the telecom company was producing. And these records were very, very tiny because it's a call data record. It's a very, very small footprint. That means you get a log of few million CDRs into one file, and then you have those flat files pushing into Hadoop. Then we do MapReduce to process those things and push it into analytics database called InfiniDB. So we were using that, and we were fairly familiar with Hadoop's capabilities. And then we thought, let's try using Hadoop. There is a project called Lily, which is created by an European-based company. Basically, what they have done is they have combined Lily and Solr, combined Hadoop and Solr, and they created a product called Lily. What it does, anything you're pushing into Hadoop, basically you index into Solr and you synchronize it, basically. So then we thought that is a classic solution for us to have a combination of Hadoop and Solr. Because Hadoop, right now there is a new version from Cloudera which has come up, which has some of the search capabilities. But when we evaluated it, those search capabilities were not part of Hadoop, and we wanted to have external tools such as Apache Solr to do indexing on top of Hadoop content. We tried that. It was highly scalable. Obviously, you can store billions of records. So you are not, and from the storage perspective, there is no issue, but there's a huge issue on the performance. What was happening is, it's all the way it is highly single-threaded synchronous API. That means all the records are kind of queued up because you need to maintain the synchronous transactions. It's a transactional process you need, and you need to maintain the transactions, and then you need to see the content in Hadoop and then the indexes in Solr are in sync. So that was killing the performance. And then we thought, okay, that is not going to help us. So what we did is, this is the third one. We looked at Alfresco. Now Alfresco out of the box has two kinds of search. One is the Lucene based, and second is the Solr 1.4 version, which comes out of the box. Even the new latest version of Alfresco comes with Solr 1.4. Yeah. So which was not a transactional way of pushing the content. So we need a transactional consistency as part of the solution. Then we went with external search engine called SolrCloud. Plus we created something called our own custom code engine called DPE, which is a data processing engine. I'm going to explain in a slide what DPE is. So we look at this solution, and then this solution was highly scalable. We did a lot of testing. We did a lot of load testing on top of the platform. We did a POC, and this was matching our SLA criteria and also matching all the enterprise content management requirements. The issue was that we need to programmatically sync the index and then the repository. That is what we have to do, because we were not using Alfresco's search indexing capabilities. We bypassed that and then hooked up our own external search engine into Alfresco, basically. So that is one issue. Second is because we were introducing a new custom module called DPE that requires support, because that's not part of the regular product support. So we looked at this, and this matched the criteria well. So we took this as the platform for us to implement it. Alfresco has a big content platform. That's what we have selected. Now, I'll basically quickly go through a couple of slides on the technology architecture. We use Solr Search, and we have data processing engine using the standard Alfresco's repository. So this is the software. We used version 4.1.4. Database, the customer is already using Oracle 11G. So we used the same thing where they already have the IT infrastructure and trained resources, DBAs to manage it. And then file storage, we use something called Veritas clustered file system. So I'm going to have a slide explaining some of the choices we have made and why we have made those choices to design the system. And very, very interesting thing is we have created our own application server, which is the DPE. The platform for DPE, for data processing engine, is Node.js. How many of you have heard about Node.js? Cool. Node.js is basically a non-blocking I/O model. We don't want a blocking I/O model because of the real-time applications, the amount of interactions we are going to have from the processing the documents and so on. And then we used a third-party tool for converting PCLs to PDF called PageTech. And the customer is already having enterprise service bus. There are a lot of third-party applications calling the API we have created to push and pull the content. So we were going with the ESB, Enterprise Service Bus. They already has Oracle ESB. So this is the kind of software we have used. So this is the DPE, which is the data processing engine. Okay. Now, what we have done is we have isolated the storage as ECM in Alfresco. Yeah. And then we have search isolated. So why we have created this model is that we were using one instance of Alfresco. So later on, if you want to scale and have multiple instances of Alfresco, then you have ability of having the multiple boxes in the architecture. Using multiple instances of Alfresco can use the same instance of SolrCloud. Yeah. So that is the key of this kind of having this kind of architecture. And then later on, for example, if we have a choice of making some of the changes to these modules, so these modules are isolated, so you can change it in future depending upon how some of these technologies evolve over a period of 3 to 5 years and so on. So the DPE is asynchronous I/O, as we said, because to get the kind of throughput we want, and we have done lots of testing on this to test it out. Very two important key elements which were missing as part of the Alfresco report or Alfresco functionality, that's the reason why we had gone with external SolrCloud, is one is transactional consistency, and then we need eventual consistency. That means for some reason, if we have a duplicate record coming in when we are indexing in Solr, we find that the record is a duplicate or some errors, we have an option of rolling back. That it rolls back, it removes it from Alfresco. So it first pushes into Alfresco, then goes to Solr. Obviously, it's queued up as part of the Node.js engine. Then when we are trying to push into SolrCloud, based on certain metadata combination, we know whether it's a duplicate record or a unique record. If there's a duplicate record or there are any issues, then we roll back. So that is what is the transactional consistency we wanted in the architecture. SolrCloud. So there are a lot of production instances of SolrCloud, more than 3 billion. We have one of the customers using it for more than 3 billion objects. So it is highly scalable, high performance. What is very important is because the nature of the documents and then the nature of the search we do is basically date range based queries. So what you can do, you can shard the indexing on the date range based sharding policy. That means you can have 10 servers where you're storing the indexes, and you can define server 1 is all my documents dated in year 2003. Server 4 dated 2004, 2005, 2006. So you can basically specify the date range while separating the indexes when you're sharding these servers. It gives you a great ability of isolating the search and getting the results very quickly back from the system. So that is one great advantage with this. And then another cool thing is you can have multiple Alfresco repositories using the same thing. That means if there is a requirement of certain state government or counties to have a totally isolated instance for the repository, you can move it into a different Alfresco, but it still be part of the same architecture. Yeah. We used a Veritas cluster file system because it supports 256 terabytes of capabilities. Yeah.
Can you explain what's the difference between the separate SolrCloud versus just Solr? Like, what's the basic difference?
The Solr, yeah.
Oh, okay. What's the difference between SolrCloud and just plain Solr that comes with?
So the question is the difference between the SolrCloud, yeah. Yeah. So what it does is SolrCloud allows you to have clusters of combination of Apache Solr and Zookeeper. It's called a SolrCloud. That means you can have sharding done You can define how you want to separate the storage within the way you are going to index and store the content in Solr. Typically, Apache Solr also gives you a clustered deployment, but it will not allow you to do sharding. That means you cannot separate the indexes based on certain criteria. Now, what happens is that when you are having a sharded deployment, that means if you have the Solr distributed on multiple servers, then you need to manage the sync. You need to have an application which manages those sync. That application is called a Zookeeper, which is another very, very popular Apache project used as part of the Hadoop ecosystem. So SolrCloud is a combination of Apache Solr and Zookeeper, again bundled as SolrCloud. Yes. Yeah, it could be done, yes. So the question is, go with a small scale implementation with out of the box with Apache Solr, then later on you want to move to SolrCloud. Is it possible? Yes, it's possible. Any questions?
Are there any questions?
No, this is not out of the box Alfresco. Yes, we did. Yes, it works fine. We have used for one of the high-tech companies here where they wanted to have faceted search, which was not part of Alfresco out of the box. Then we used regular Apache Solr.
So your sharding strategy, did you do that by counties so you could isolate your data? Or are you violating your isolation of data by having it all in one area?
So basically there are two different. One is isolation of data only for binary content. The sharding is not isolated. Still the search index is common across all the points.
And they were okay with that?
Okay, any other questions?
Sorry? No. No encryption. That would have created a whole lot of complications on top of that, yes. Fortunately not. Yeah, yeah, right.
The basic engine which made this possible processing engine that you had, if you take that out of the picture, what kind of capability just Alfresco with Solr gave you? Like, see, because for a normal customer, you know, they may not have access to the data processing engine you're talking about. So what kind of capability Alfresco?
Good question. The question is, what are the capabilities of the system without DPE, basically. So the classic thing is that the separation, the way we created a taxonomy to store the content was unique. In this case, what happens is we have state-specific requirements stored in a specific Alfresco share. Within share, we have a taxonomy of the folder structure. For each county, there's a separate folder structure, again, which is a year, month wise, and then there's a separate program based file system. So what happens, the moment you are pushing the content into the file system, there are a lot of business rules applied on each folder structure. So as and when the content is being pushed into the folder structure, it's a recursive business rule. So if you are in the folder level 3, then the business rules from level 3, level 2, and level 1 will be applied on the content. Then, for example, adding some of the aspects dynamically, some of the processing we do, kicking some of the workflow, kicking some of the notifications, all of that was possible with Alfresco, which was not there in any of the other big data platforms we evaluated. Yeah. Yeah. So we have not used Alfresco, or we have not used Alfresco's out-of-the-box Solr implementation. We have not developed new. What we have done is basically there is a way of bypassing the search engine and directly pushing into it. Yes. Yeah.
So you were basically like reading their transaction logs and then writing into documents, right?
Correct.
To your SolrCloud, so that's.
No, it's not. It's,
How would you be triggering the write? Because if you just enable Alfresco's
Third.
yeah.
indexing, you need some way to put the content.
Correct. Yes. Correct. That is what DPE was doing. That is, we were controlling the processing.
Right, but if you driving out like a transaction log.
No. Because we are the API. There is no direct access, so it's all controlled through the DPE. If you look at the architecture I've shown, nobody will directly access Alfresco. They have to go through the DPE. So we know exactly what is being written and what is being searched and so on.
Yeah, that's what I meant by the transaction log. There's an Alfresco table that is the list of transactions that haven't been indexed yet.
No, that transaction log is maintained and controlled by DPE, not by Alfresco, in this case.
Okay.
Yeah.
So you used Alfresco just as a file repository.
We used Alfresco as a secure, scalable file repository which gives us ability to define the business rules, trigger the workflows, trigger notifications. It has a lot of audit trail. We do audit logs. Actually, I missed showing one slide perhaps. So we do audit trails, and then we do the backup policy, and then we have shared sites where we have defined the taxonomy for the folder structure and all that.
Okay. So we are running out of time. I think
Yeah.
you have some time after our talk to
Yeah.
discuss all the other questions. So.
Cool.
Okay. Sorry.
Thank you so much for coming in.
Thank you.
Yeah, welcome. Yeah.